Ed Golod Speedcast here again with my client and partner and friend, Andy Lee from Vincere, COO, co-founder. Andy, good to see you.
Good to be back again.
We love having you. Okay, so today we're going to take a really, really complex question and have you translate it into English and then put the money behind it. Really tough question. This is like Jerry Maguire on steroids.
It's a tough challenge. I'll see what I can do.
All right. Well, I know you're never going to let me down because you haven't yet so far. So for the folks following us and the new ones joining, welcome. There is a technology approach here to curing Parkinson's. This is not make a pill, serve a pill, cure a relative or a person. Andy, tell us about the idea of a technology platform and how you ended up with about, I think, 10 AI structured data tools along the cure for Parkinson's. Please.
Yeah, it's been an interesting experience. And, we started out with this idea that it wasn't clear what the root cause of Parkinson's is and where the best intervention would be. So we built a set of tools that would point us in the right direction, that would take human genetics and find a most probable target that you should intervene, that you should create a drug for if you could, and point us in the right direction for that development. Well, once we did that, then we wanted to look at how do we know that this thing is likely to work? Testing things in mice has led people astray in these diseases for years, and there really aren't any great models of Parkinson's disease before you test it in a human. So we created another tool that would take the profiles of patients and create a simulated patient brain cell so that we could test these hypothetical therapeutics in a computer before we spent all the time and money to make something in the real world.
Hey, let me understand this in translation. When you say tool, you're talking about an IT technology software tool with a biological front and back end engine. And then when you made the tool, the way my dad used to make tools working on cars, the tool was enabling you to find an answer to the problem. And when you were done, you ended up with a tool that somebody else could use. Mm-hmm. Do I have that right?
Yeah, that is. We started with a series of problems that come between I have a problem I want to solve and I have a drug that works in the clinic. And as you work through that process, every step of the way, we found there's some gap that could be solved with better technology to make sense of this massive amounts of data that are coming out. And so we had to build a new tool. Once you've built that tool, that's reusable across any disease and any gene and any target, right? So we've now got this suite of tools that could take any problem, tell you what's going on in that complex biological system, find initial chemicals that might modulate that, and then make sense of which patient you should test those compounds in the clinic.
This is crazy. And because you are a biotech, deep biotech, you did that. If you were really just working on a cure and you had a tech division, you probably wouldn't have been able to pull that integration off. So in essence, you might have still found an answer to that single problem, but now you have a tool. And if I was going to invest in your company, and I could get in for, small money, middle money, big money, I would then be able to understand, wow, maybe you guys are going to take these tools that you have and help other companies making cures for other diseases. So you're actually have an ability to make money on the tools that you're building to find a cure for Parkinson's. I have not seen something like this literally ever. But then again, I don't represent the medical community. Am I wrong in that thought or am I right in that thought?
No, it's a good point. And it's something that we've had in the back of our head that when making new tools, you've got this challenge of, how do you prove that they work? And for something like developing new drugs, you don't really know if the predictions you made at day one are right until you get through human clinical trials. right? Because we don't trust any of the animal stuff in the middle. So our philosophy has been to create the drugs, carry them all the way through. And as we get further down the road and we have confidence that like what we've been doing is right, we'll then be able to take that and scale it back out to other groups. What we're finding is we don't actually have to get all the way to the end state of a cure that's out in patients in Parkinson's. We've gotten far enough down the road with enough different types of drugs. We now have 4 small molecule drug programs that are running in parallel that have come out of this platform with amazingly little capital compared to what most teams do, that pharma partners are starting to take notice. They're interested. And, we're starting to get people questioning, well, how did you pull that off? How could we do that?
You're not talking pharma partners. You're talking big ass pharmaceutical companies. We're talking the giants of the world.
Yeah, like
the 50, $100 billion companies.
Exactly.
This is incredible. So this is leading us to probably our next recording, which we'll do on the finance behind this, not the financing getting you money, but the financing you returning money. It's an honor and a privilege to work with you, because I don't find more companies explaining to investors, this is what it is. This is what it does. Here's how it develops over time. Here's the risks, and here's the reward. You approach a cure for Parkinson's from not just a cure perspective, but a business perspective. And that's why I'm sitting here, because it's an honor to do it. This is Ed Golod at Speedcast with Andy Lee from the Terry Biosciences. It's been a crazy call, Andy. Thank you.
Thanks, Ed.